Hi everyone. Today we'll be solving the question from Striver SD sheet, that is inversion of array, also known as count inversions. The question says that given an array of integers array, find the inversion count in the array. So we have to find the inversion count in the array. There are two conditions to solve this problem. Like the two elements should of array I and array j, from an inversion it should be like array I should be greater than array j, and the index of array I should be less than j. Therefore the c here, the value of array I should be greater than the value j. This is the first condition, and index of array I should be less than the index of array j. And it also says that for any inversion count indicates how far or close the array is from being sorted. If the array is already sorted, then the inversion count is 0. Definitely, if the array is sorted, definitely the inversion count will be 0. I'll tell you how. Here, if you see 1, 2, 3, this is having an inversion count of 0. Why? Because this array of I should be greater than array of j, that is 2. 1 is less than 2. Again, 2 is less than 3. 1 is also less than 3. So this is not gonna have any inversion count. If any array is sorted in the reverse order, then the inversion count is maximum. And now if it is completely opposite, okay, this, how many inversion can you see? 3, right? So total number of elements present, basically, then it becomes. So anyway, now let's see how we can solve this question. Again, it's an array question. Most of the array question will always have any matrix thing or any of those search operation we have to put in maximum array questions, like linear search, purple sort, any of the sorting techniques. What if you see here, like 2 is greater than 1 inversion count, right? 2 1. Again, 2 less than anything? No. 4 is greater than 1, so 1 inversion. See, again 4 is greater than 3, therefore 1 more inversion. If you can see, like I've taken this, then these, like 1, then again leaving this. Brute force will be, of course, how you can think. The brute force is like just check, have two for loops together, just checking if this is greater than this or not. That's the brute force for this. Like I will have two for loops. I'll just do ChatGPT and show the brute force for this. So this question is a bit very big. So in interview, I don't think, if it's a 45 minutes interview and they're asked two questions, then I would suggest not to go to the brute force, right? Just the pseudocode for the brute force. Just directly go to the optimal, because this is the biggest one, right? So the brute force is this. See, I told you I will have two for loops, I equals to 0, and then I is less n minus 1, and then if I'll check 2 with 4, again 2 with 1, again 2 with 3. If array of I is greater than j or not, then count plus inversion count, and then finally return that. This is simple brute force. Now coming to the optimal. How can you think of the optimal approach? I hope all of you have studied Mart sort, okay? This question is basically the implementation. It teaches you the implementation of Mart sort, only one catch point is that you have to count the inversion. Therefore, we have to take one extra variable, that is count, for the final answer. And then I'll just have this one extra line. Everything is just taken from Mart sort, and finally I will, in the inversion count function, I will return the Mart sort function. As simple as that, using recursion, of course. This is basic recursion things I have done here, and the main code is inside the merge function. If you have not studied merge sort yet, then please go and watch it from Striver sir. And so how the merge sort is basically done, I'll show you from GFG. Merge sort GFG. See how merge sort is basically done. If I zoom this, so basically this is an array of 4 numbers, and this will be divided, like you must have studied about divide and conquer. So this will be divided equally. And then see, this array is divided first to 30 and 27, and then 43 and 10, and then again to 38 and 27, right? And then again 43 and 10. And now I will sort it. Final, see, for at first we will divide this array, okay? Until and unless every element is single, we will divide the array, right? After that we will merge the array. Okay, at first our work in merge sort is divide the element divide the array until every element becomes single. Okay, that is our first task in merge sort. After that we will now, after dividing is done, now we have to merge it, bring them back together, but in this time in a descending order or in a sorting manner. So the way you want, sorting can be ascending or descending. So now 27 will come and 38 will come, and here 10 will come beginning and 43 will come at the end. And after, when we merge both of this, definitely 10 will come, then 27, then 30, then 43, right? So this will be our final merge sort answer. How this, like, you can, to sort any array you can use merge sort also, right? Now if you see, so I have taken, of course, this is the left. For this I have taken a left pointer, and this is the mid. Therefore I have taken a mid pointer, and this will be the high. I have taken a high pointer. This is the left pointer, which will lead the first partition of the array, and the mid will lead the second partition, first index of the second array, right? And the high will be at the last of the end of it will point at the last of the array, end of the array. So I've taken a temporary array where I'll be performing this merge sort, right? Then I've taken a left, which is low, and the right mid plus 1. Right is basically this one, the right pointer, and then I've taken a count for this particular question. Otherwise in merge sort you won't see this count thing. Of course you don't want to count in merge sort, you just want to sort that particular array. So now while left is less than is equals to mid, definitely while left is less than is equals to mid, till they are equal, and also mid should be less than, that is right should be less than is equals to high, and then left plus plus. Sorry. Now I will check if left, what was our condition? This left part should be, our condition was, you just could have write it there. So if our condition is that left should be greater, so we are just doing, if left is not greater, then just push it back to the temporary array. Okay, that means we are just dividing the array till now. But if left is not greater, at that case what we will do, if left is not greater, then also push it in the margin, in the temporary array, in the temporary vector that we have taken here. Also count the number of inversion. This is the one important line for the counting inversions. And if by chance, if any of the, suppose, now I will just explain. Suppose this is the part. Okay, for this example, if we take, here this sucks. So if we take this example, so the, how the merge thing will work, 2 4 2 4 1, and then 3 and 5, and after that 2 will be again here with 4 and 1, and for 3 and 5 will be different. And now 2 comma 4 comma 1, and then 3 comma 5. See, all of them are equally all of them are broken into single element, right? And after that finally I'll merge it, check. So at the end, like, see, this will also come. Okay, now what merging thing will happen, if we have seen here. Okay, So 2, if you can see from here, if you just relate, यार ऐसे क्यों हो रहा है? Okay. So now after merging, how this will work? Just think. 1 will come, right? Then 4 will come, right? At any time, if you can see, if left half are still left, this is the left half. Okay. See, at a point where after merging, what will actually happen is that 1 will come, 2 will also come. Suppose this is just replacing 4 with 6, okay? Think all of this 4 as 6. Just think all of this 4 as 6. 1, comma 2, comma, then 3 will come, right? And 5 will come, and then 6 will be left. So at that time, when anything is left, left is equal to thing, then just push that element. Same thing right side also can happen. If any of the element at the right side is left, that is this side is left, then we will just push it there, right? In the temporary vector. And after that, finally all the elements are sorted. And now we will finally store it to our main array from the temporary array, right? We are gonna store it in main array from temporary array, right? And finally return the count. Okay, so this is how this is actually working. And now if you see another thing, okay, so finally returning the count. And one more portion that I have to explain is this part that I will explain. Just give me a time. And this is all a basic recursion thing, taking a count and how low and high pointer is gonna work, and mid is equals to low plus high by 2, right? And definitely the count will be this smart. This recursion, 3 of the recursion will work. This is basically for the low and mid, and then first part of the array for this part, and for this line is for this part, that is from mid plus 1 till high, that is 10 here. And then finally merging the count completely. When you merge, this is definitely from low, mid, everything is gonna come, right? Low array will come, definitely low, mid, high, everything is gonna come. And then finally return the count, and inside this inversion count function we will return the merge sort function, that is array 0 until n minus 1. This is the simple thing. And now this part you might get confused. So in this example, I'll tell you how. Sorry, just removing all of this. In this example, you can see, just taking the first part, okay, 6, 1. After we sort this, how it will be 1, 2, 6. And for the second part, when the sorting thing is done, right? So when like 3 is gonna, if you see here, 1 is here, 3 is here, right? Definitely. So now what is gonna happen? Just check once. Is 1 like, if 1 is, this is not the the right example to understand, but okay, I'll just change the values to 2. Yeah, this is the proper example. When this left pointer, this is the low pointer, and this is the mid pointer. So now 2 is our condition is that this should be, array of I should be greater than array of j. So 2 is greater than 1, definitely. So that this is already sorted. So definitely these will also be making a inversion, right? Therefore that is why I have written this, that is 1 minus 2 plus 1. Or you can say this portion is basically mid plus 1. So they take it as 2 minus, this is 0 plus 1, which actually gives us 3. So that is why we are getting 3, because see, 2 will form in inversion count with 1 also, and it will form an inversion count with 3 also. 1 will form inversion count. See, since 1 is less than 2, so it must be, if the array sorted, the rest of the elements are also gonna make a inversion count with 1, right? That is the catch. Therefore we are just gonna minus all of the elements, and then finally for just do it in one go, so that it doesn't take too much of time. That is the catch point of this complete. But now the complete thing is a everything is marked sort here except this one line and this count variable. So now if we just check what will be the time complexity. Okay, so the time complexity for this one will be, see, we have taken a let's discuss the space complexity. We have taken a temporary array, therefore the space complexity will be big O of n, right? Just writing it somewhere here. The space complexity will be big O of n, and the time complexity will be big O of course, you know, this is a mad sort, something sort for while loop, big O of n that we can write. And then this thing is happening, so this again log n. If you have studied binary search, you will understand how this is happening. So big O of n log n is the time complexity for the solution. I hope you understood. If you did, please keep late coding. Bye.